students, we'll start with geometry revision. This is the last revision worksheet. Now this worksheet contains the questions of chapter number 4, that is geometric construction, and chapter number 5, coordinate geometry. Now we will not solve all the sums. All the sums we have solved. We will take few sums. I will teach you few sums, and few will be homework which you have to do in your notebooks. You can do later also. So we'll start with now question number 6. Find the distance between each of the following pair of points R 0, -3, S 0, 5/2. So here we know R, which is x1 is 0 and y1 is -3. For S, x2 is 0 and y2 is 5/2. So you have to find the distance. So we use the distance formula. So by using distance formula, we know distance between RS is, the formula is x2 minus under root x2 minus x1 the whole square plus y2 minus y1 the whole square. So now I'll substitute the value. See, x2 is 0 minus x1 is also 0. So 0 minus 0 the whole square plus y2 is 5/2 minus, and in y1 we have again minus. So minus of minus is plus 3. So now we know 0 minus 0 will be 0 only. So 0 square plus, now see 5/2 plus 3 means it is 3/1. As the denominators are not equal, so we will make it equal. So when you cross multiply, 5 ones are 5 plus 3 twos are 6 upon 2. So we get 11/2 the whole square. 0 square will be 0 only. Now 11 square is 121 upon 2 square is 4. By taking square root, we get 11/2 units. I am not taking all the sums. I will be taking few sums. So at the end of this worksheet video, I will clearly tell you which sums will be the homework sums. So we'll move on to next question now. That is, find the centroid of the triangle whose vertices are given below. -7, 6, 2, -2 and 8, 5. So we will say that let A is 7, 6 which is x1 and y1. B is 2, -2 which is x2 and y2. And C is 8, 5 which is my x3 and y3. So now let G, that is x, y be the centroid. So by using the centroid formula, we know the formula is x is equal to x1 plus x2 plus x3/3 and y is equal to y1 plus y2 plus y3/3. So we start putting the values now. See, x1 is -7 plus x2 is 2 plus x3 is 8/3, and for y1 is 6 plus y2 is -2. So plus of minus will become minus. So we get -2 and plus y3 is 5/3. So when I simplify this, see what we get. For x, -7 plus 2 will be -5 and -5 plus 8 will be 3/3 which is equal to 1. And for y, 6 minus 2 will be 4. 4 plus 5 will be 9. 9/3 will be 3. So the centroid has the coordinate G, that is 1, 3. Now we'll move on to next question, that is determine whether the points are collinear. So A is given, C 1, -3, B is given 2, 5 and C is given -4, 7. So here what we will do, we'll use the distance formula. First we'll find the distance between AB, then we'll find the distance between BC, and then finally we'll find the distance between AC. So all three will compare, and then we'll say that whether the points are collinear or non-collinear. So see, first I will take AB. For A, x1 is 1 and y1 is -3. For B, x2 is 2 and y2 is -5. So by using distance formula, we know distance between AB is under root. The formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. Now I'll start putting the values. x2 is 2 minus x1 is 1 the whole square plus y2 is -5 minus, and y1 is -3. So minus of minus becomes plus here, plus 3 the whole square. So 2 minus 1 will be 1 and -5 plus 3 will be -2 the whole square. So 1 square will be 1 and -2 square will be 4. So 1 plus 4 will be 5. That will be my statement number 1. Now see, we'll take the distance of BC. So for BC, we know x1 is 2 and y1 is minus 5, x2 is minus 4 and y2 is 7. So again we'll use the distance formula. We'll substitute the value. C. x2 is minus 4 minus x1 is 2. So minus 4 minus 2 the whole square will be minus 6 the whole square, plus y2 is 7 and y1 is minus 5. So minus of minus becomes plus. So plus 5. 7 plus 5 will be 12 square. So when you square this, minus 6 square become 36 and 12 square will be 144. So 36 plus 144 will be 180. So 180 what we will do? We will take for 180 36 into 5. So 36 is a perfect square root will be 6 root 5 unit. That will be my statement number 2. And now finally I will go for distance of AC. x1 is 1, y1 is minus 3, x2 is minus 4 and y2 is 7. Again we will use the distance formula. So see, x2 minus x1 the whole square means minus 4 minus 1 the whole square will be minus 4 minus 1 will be minus 5 the whole square, plus y2 is 7 and y1 is minus 3. So 7 minus of minus becomes plus 3 the whole square. So 7 plus 3 will be 10. So minus 5 square will be 25 plus 10 square will be 100. So 25 plus 100 is 125. So what we will do, we'll take 25 into 5. So 25 is a perfect square. The root will be 5 and root 5 remains same. That is statement number 3. Now see, I will compare all three statements. AB is root 5. Statement 1. Statement 2. Distance of BC is 6 root 5. And statement 3. Distance of AC is 5 root 5. So from 1, 2 and 3 what we get, see, 5 plus 5 root 5 will be 6 root 5. So that means when I add distance of AB and distance of AC, I get distance of BC. So here it is equal. So we know that distance of any two points are equal to third, then the points are collinear. So I can say that ABC are collinear. Now we'll move on to question number 9, that is show the points. See, points are given P, Q, R, S. Coordinates are given for all and you have to prove that they are the vertices of a parallelogram. So P, first what we will do? We will find distance of PQ. So see, P is given 2, minus 2, which means x1 is 2 and y1 is minus 2. And Q is given 7, 3 means x2 is 7 and y2 is 3. So we will use the distance formula. We know the distance formula is under root distance of PQ will be equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Now x2 is 7, so I will put 7 here, minus x1 is 2, 7 minus 2 the whole square plus y2 is 3. In formula we have minus and y1 value is minus 2. So minus of minus will become plus 2 the whole square. So 7 minus 2 will be 5 the whole square plus 3 plus 2 will be again 5. So 5 square plus 5 square will be equal to 25 plus 25 will be 50. So I will keep this as it is, that is distance of PQ will be 50 units. That will be my statement number 1. Now students, I will go for distance of QR. For QC, x1 is 7 and y1 is 3. For R, x2 is 11 and y2 is minus 1. So by using distance formula, again I will use the distance formula and substitute the value. See, x2 is 11 minus x1 is 7 plus y2 is minus 1 minus y1 is 3. So I will simplify this. See, 11 minus 7 will be 4 the whole square plus minus 1 minus 3 will become minus 4 the whole square. 4 square will be 16 and minus 4 is also square will be 16. So 16 plus 16 will be 32. So we get 32 units. Now we'll take distance of SR. For SR, again see, x2 is 11 minus x1 is 6 plus y2 is minus 1 minus and y1 is again minus 6. So minus of minus becomes plus 6 the whole square. So 11 minus 6 will be 5 and minus 1 plus 6 will be 5. So 5 square plus 5 square will be 25 plus 25, that is 50 units. So distance of SR is 50 units. That is my statement number 3. And finally, now we will find the distance of PS by using the distance formula. To see, x2 is 6 minus x1 is 2 plus y2 is minus 6 minus and y1 is minus 2. So minus of minus is plus. So 2 square. So 6 minus 2 will be 4 and minus 6 plus 2 will be minus 4. So 4 square will be 16 and minus 4 is also again 16. 16 plus 16 is 32 units. So distance of PS is 32. That is my statement number 4. Now see, we will compare all. So when you compare 1 and 3, see 1 and 3 was distance of PQ and distance of SR. These both were equal, which was 50 units. And statement number 2 and 4, we got that distance of QR and PS are equal, that is 32 units. So in a parallelogram, the opposite sides of quadrilateral are congruent. That means the given points are the vertices of a parallelogram. Now question number 10. Find the coordinates of point P if P divides the line segment joining the points A, that is minus 1, 7 and B 4, minus 3 in the ratio 2:3. So now here we will use the ratio is given, means we will use section formula. So A is given, see x1 is minus 1 and y1 is 7, x2 is 4 and y2 is minus 3, and the ratio of m is to n will be 2:3. So by using section formula we get, for x we have c mx2 plus nx1 upon m plus n, and for y the formula is my2 plus ny1 upon m plus n. So now see, I will substitute the values. M is 2, mx2 means m is multiplied by x2, x2 is 4 plus nx1 means n is 3 multiplied by x1 is minus 1 upon m plus n means 2 plus 3. This was for x, and for y see now my2 means m is multiplied by y2, m is 2 multiplied by y2 is minus 3 plus ny1, n is 3 multiplied by y1 is 7 upon 2 plus 3. So when I simplify this, see 2 4s are 8 and plus 3 multiplied by minus 1 will be minus 3 upon, in denominator we have 2 plus 3 5. So 8 minus 3 will be 5 upon 5, which is equal to 1. And for y see 2 into minus 3 will be minus 6 plus 3 7s are 21, minus 6 plus 21 will be 15 upon 5, which is equal to 3. So x is 1 and y is 3. So the coordinates of point P is 1, 3. Now we'll move on to question number 11. A h, minus 6, B 2, 3 and C is minus 6, k are the coordinates of vertices of a triangle whose centroid is, see centroid is given, that is G 1, 5. Now you have to find the value of h and k. So here we will use centroid formula. So first we'll write what is given, see A h, minus 6 means x1 is h and y1 is minus 6. B is given 2, 3. So x2 is 2 and y2 is 3, and C is given minus 6, k means x3 is minus 6 and y3 is k, and the centroid, that is G 1, 5 is given, means x and y is given. So by using centroid formula, the formula is for x x1 plus x2 plus x3 upon 3, and for y y1 plus y2 plus y3 upon 3. So x is given, the value of x is given, so in place of x say I will put 1 is equal to x1 is h plus x2 is 2 plus x3 is minus 6 upon 3, and for y is given 5, x1 is minus 6 plus y1 is minus 6 plus y2 is 3 and y3 is given k, so plus k upon 3. So see, I have 1 on the left hand side and 3 in the denominator of right hand side. So I will multiply 1 into 3 will be 3, and here see h remains as it is. Now plus 2 minus 6 will be minus 4, and for y see again 5 on the left hand side and we have denominator as 3 on the right hand side. So 5 3s are 15, minus 6 plus 3 will be minus 3 and plus k remains same. Now we'll take all numbers on same side. So what we will do, 3 remains on left hand side From right hand side minus 4 I will shift to left hand side, becomes plus 4. So 3 plus 4 will be 7. So value of h is 7. And see here we have 15 on left hand side. Minus 3 from right hand side I will shift to left hand side, becomes plus 3. So 15 plus 3 will be 18. So the value of k is 18. So h is 7 and k is 18. Now we'll move on to next question, that is, if a minus 14 comma minus 10, b 6 comma minus 2 is given, find the coordinates of the point which divide the segment AB into 4 equal parts. So see, I have made the segment AB and I have taken 3 points PQR which will divide the segment AB into 4 equal parts. See, AP will be equal to PQ, will be equal to QR, will be equal to RB. So we'll write that let PQR be the points which divide the line segment AB into 4 equal parts. So what we get, AP is equal to PQ is equal to QR is equal to RB. So first what we will do, see, Q is the midpoint of segment AB. So I will use midpoint formula. So see, what I will write now, A is minus 10, minus 14 comma minus 10, which means x1 is minus 14 and y1 is minus 10. B is 6 comma 2 minus 2. So x2 is 6 and y2 is minus 2. Q is the midpoint of segment AB. So let the coordinates of Q be x comma y. So by using the midpoint formula, when the formula is, for x we have x1 plus x2 upon 2 and for y we have y1 plus y2 upon 2. So x will be, now see, x1 is minus 14 plus x2 is 6 upon 2. Minus 14 plus 6 will be minus 8 upon 2. So minus 8 divided by 2 will be minus 4. And for y, see, y1 is minus 10 plus and y2 is minus. So plus of minus will be minus 2. So minus 10 minus 2 will be minus 12 upon 2, which is equal to 6. So I got the coordinate of point P, that is minus 4 comma minus 6. Now if you see that, I got Q. So now P is in between AQ, means P is the midpoint of segment AQ. So what we will do? We will find the coordinates of P. So see, A, Q. X1 is minus 14, Y1 is minus 10, X2 is minus 4 and Y2 is minus 6. So let the coordinates be P, that is x comma y. By using the midpoint formula, the formula is for x we know x1 plus x2 upon 2 and for y is y1 plus y2 upon 2. Now see, x1 is minus 14 plus x2 is minus 4. So plus minus becomes minus, so I am writing minus 4 upon 2. Minus 14 minus 4 will be equal to minus 18, which is divided by 2 will give us minus 9. And for y we have, see, y1 is minus 10 plus again y2 is minus 6. So plus of minus becomes minus 6. So minus 10 minus 6 will be minus 16 upon 2, which is equal to minus 8. So the coordinates of P are minus 9 and minus 8. And finally now we know that R is the midpoint of QB. So x1 Q is minus 4 minus 6 and B is 6 comma minus 2. So x1 is minus 4 and y1 is minus 2 and x2 is 6 and y2 is minus 2. So let the coordinates be x comma y, will take it as R. So by using midpoint formula we know, see, x1 is minus 4. So I will put the value in the formula. See, I will substitute the values. x1 is minus 4 plus x2 is 6 upon 2, minus 4 plus 6 will be 2 upon 2. And for y, x1 is minus 6, sorry, y1 is minus 6 and y2 is minus 2. So minus 6 minus 2 will be minus 8 upon 2. So when you divide this, x, that is 2 by 2 will get 1 and minus 8 divided by 2 will be minus 4. So the coordinates of point R is 1 comma minus 4.